Hi, Jim Berthold here again from OLI Systems with another video on how we use our software. This is a follow-up to a video we had several months ago, and we'll put a link in the description about managing solids to get a more accurate representation of what is going on in the solution. So in the previous video, we were looking at the solubility of calcium carbonate is both calcite and aragonite, and we're doing a similar thing here. Okay. So I've partly set up this case already. Let's go through the chemistry. It's very simple. It's just water and calcium carbonate. And although we don't have a precipitation point calculation in OLI Flowsheet, so we're going to have to mimic that by adding some feeds with the controller. So I'm using a separator here. The water feed is very simple. It's just a 55.5 moles of water, which is a kilogram of water. And I could actually change that into mass units if I want. And you can see it's nearly a kilogram. I'll make that exactly a kilogram. And we have our carbonate feed here. I'm leaving this in moles here. And it's just one inflow of calcium carbonate in any form. So I'm going to control the flow of this carbonate feed such that I have a solid feed, a solid product coming at the bottom, and that will be the saturator. So I've created this controller, and now I need to adjust something. And this is a relatively new feature in OLI systems. I'm going to actually control the stream directly. Before, in earlier versions of OLI Flowsheet, you would need to add a manipulator block, but now we can control the flow directly. However, the controller does need some specifications. We are going to control true species. That's here. Let's see if we can make this just a tad wider. Based upon moles, I do have to pick the species I want, and I've already selected calcium carbonate. I have given it a target, and now I have to tell it what I'm adjusting. I'm going to adjust a stream directly. Here it can only be an inlet stream directly. And the name of that stream is carbonate feed, and the parameter will be total flow factor. This is very similar to what we've done in the past. So I'm going to go ahead and run it. And it has run very quickly. Let's go look into some products here. So first off, let's take a look at the call out of the carbonate feed. It is a solid only feed, so pH doesn't make too much sense, so we're going to get rid of it. Okay. But I do have some solids. Calcium carbonate is the... let's not pick that one. Let's just look at the total moles of that stream. And we'll move things around to make it a little clearer. So it looks like we have a solubility of about 2.3 moles per kilogram, because we're going to ratio between that and the other feed. Let's take a look at the solid. We're going to add a call out there as well. Again, solids don't have pHs, so we're going to get rid of that. And we're going to look, in this case, of some of the actual solids. Now, for the tutorial, I actually want to look at another solid. So I'm going to uncheck the hide zeros button and add aragonite. For those of you who have seen the previous video in Studio, you'll understand why I'm doing that. Okay, and we need a little bit more room here. There we go. So that was the spec, and I wanted to get that amount of solid calcium carbonate. That's what's coming in. So that's the solubility, about 2.3 times 10 to the minus 4th moles. It's always a good idea to save your case, so I'm going to do that. I'm going to change the spec. Let's look at the solubility with a different solid. As in the previous video, I mentioned that there are other forms of calcium carbonate. Aragonite is a very common form. Aragonite does not normally form out of pure water. It will form out of solutions that contain a significant amount of magnesium. If you put enough magnesium in the water, it prevents the calcite crystal phase from forming, and you get an aragonite crystal phase. If you put enough magnesium, you get yet another phase, called vaterite, and find enough magnesium in solution, you get what's called dolomitic calcite. So we're going to just simulate a more real-world condition of precipitating out aragonite instead of calcite. And we do that by changing the controller, and we're going to change the target from calcium carbonate to aragonite, and we're going to go ahead and run it. It runs quickly, but it gives us this error message. So we should go down here and look in the error dialog to see what happened. And it says the controller did not converge in a maximum number of iterations of 20. That's the default number of 20. But we can already see that we have a problem. We spec'd aragonite as our solid, but calcite's coming out because we know it's the more thermodynamically stable phase. So that can't be right. So we're going to change the chemistry. And that's really the point of this video. So we're going to go into the chemistry tab, and this is similar to what we did in Studio, but we put the phases tab more directly out there. And since we're looking at various forms of calcium carbonate, we are going to remove the oxide and hydroxide. We're going to remove the calcite and just leave aragonite as our species, similar to what we've done before. And we'll go ahead and rerun it. Okay, there are no errors. And you can see that we've precipitated out aragonite. And we've got a slightly higher value of the feed of the carbonate. It was 2.3 before, now it's 2.5. So this is a way we can change the chemistry to model a more real-world solution by using the chemistry model option. I did forget to tell you earlier that we were using an MSC model, but that's not really important for this tutorial. But I can tailor my model by turning on and off solids. So thank you for watching, and we'll see you next time.